Hello, my single linked list part 2 using the C programming language. If you guys recall my previous video on single linked list part 1 where we wrote a C programming language, we allocated a space in the memory that points to the structure of nodes in the heap memory, and we're able to store data in the member of the struct node and also print that data. Okay, but today we are going to furthermore in the single linked list, and this is the part 2 of this video. Alright, we'll continue from the previous video so that I don't get you guys confused. Alright, so we have a terminal here. We'll change to the link underscore lt, which is the abbreviation of this directory. So if I do ls, you can see the previous code we wrote ls, so we can run that code to see if everything is still working as expected. Alright, the program is still the same with the previous, which is the part 1 of this video. It gives us the same output, right? What I just added here in this program is that I added this arrow, okay, which is just a normal string in the program, and I also added this add add arrow current, because we are about to link another heap memory that will point to this structure of node and print a new data assigned to the integer of the member of the structure of node called data. Alright, so for us to be able to achieve this, I will copy this single list.c and give it another name called single list2.c. So I press enter key, ls, and that's single linked list 2, which is for this video. If I use Vim to open it, we say that whatever we have in the first single linked list will also be in the second linked list, so that we can continue writing our program from there. So single linked list 2.c, press enter, I for insertion key. You can see the whole code is the same. Alright, so what I'm going to do here is to be able to add more dynamic memory link and link it to the structure of node and assign variables to that heap memory of the member structure of node. So we are going to create another struct, okay, of node, which will be a pointer, and the variable name here should be called current. And we say whenever we do this, we should always assign the value to null, okay, so that that particular memory or space in the memory will contain 0. Remember, I told you guys null simply means 0. So when we do that, below here we are now going to allocate the dynamic memory on the heap for that current structure pointing to node. Alright, so what I will do here is to call the current. Alright, I will say current is equals to open bracket, and remember malloc returns a void, so which means we can do typecasting. So I will say here struct, alright, struct node, which want to return is a pointer because the current is a pointer back to the struct node. So we close it and we call the malloc function. So we have to give a fixed size to the malloc, so the amount of space we want for this struct node. So we are going to pass in the struct itself of node. So whatever struct node, the size of struct node is what the CPU is going to, the memory is going to give to us, the computer is going to give to us. So once we are done, we use the if statement to check for errors, which is very, very important. So what errors are we checking? We are checking for the current. Alright, so we say the current if equals to null, and that will be false because we have already assigned a memory heap, so therefore this current is no longer null. Alright, so this code here will not execute. But if peradventure there was error, we would like to see the error and know how to fix it. So we use the function called fprintf. Alright, so the fprintf will pass in the standard error and double quote the error number %d. We'll put this arrow sign just a string, then %s \n double quote no. So we get the error number and we use the error string to pass the error number and get the associated error code to that. Once we are done with that, because we encounter error, we would like to free head first and then also free current. Okay, remember the way I did it, I free head first because head was above current, and that is a good practice. Then after that, because we encounter error, something went wrong, we like to return and exit failure, which is value 1 to the computer, and we close this. But if there is no error, therefore this code here will be skipped and our code will continue below. So below the program here, what we are doing now here is that we continue from this place the program is. So what I'm gonna do is, at here I would like to add a printf here, and this printf here we say first struct node, first struct node, and I'll put 2 new line double quotes and I will close that. So instead of this head here, remember that this head is pointing to this data. If you forgot this, please make sure you watch the part 1 of this video. So we assign the value here 50 to the data structure here, of which is a data int data, which is a member of the struct node. Okay, so we assign the value 50 to it. So, and here we point to that link of that same head, which is a self-reference link to struct node, and we say equals to null. So this time, instead of null, we say let it be equals to what? Current. Alright, so the address here of head will become current. Okay, so whenever we print here, it's going to print head and the link is going to give us the address of current. So let me also free the current here. So I would like us to run the program before we continue writing the other part of the code. So for us to do this, I will just save and I'll do gcc single linked list 2, alright, .c, and I'll do -o single linked list 2. Alright, when I press enter, it compiles. So we have 2 compilation, single linked list 1 and single linked list 2. So execute the first one, so that is the output. The second one, which is 2. Now you can see first struct of node. So instead of the first one, remember the first program was name, but because of you are giving it the current pointer to struct node, so it contains the address of current, and that is why you see this string here. Alright, so what we're going to do now, since head is pointing to a link itself and it's assigned this address, so from here we can assign value to this same data to print another value. Alright, so let us do that. We'll go back to the editor to write that. So what we're going to do now, we're going to go below here. Alright, single linked list is the way you write meaningful program in C. If you don't know single linked list, I bet you can write a meaningful program in C, such as servers or port forwarding applications, or whatever you feel like that is meaningful and important to the universe. You can do it if you don't know single linked list. Alright, so do well to calm down and watch the video. And guys, remember, if you have not subscribed to my YouTube channel, if you are watching this video from TikTok, just click my profile picture and you'll be redirected to my TikTok bio, and that is my TikTok account. Then you will see a link there. Click the link, you will see YouTube. Click YouTube and you'll be redirected to my YouTube channel. There, make sure you subscribe to my YouTube channel, so that whenever I drop a new video, and you will receive notification. Okay, so let's continue. So what am I gonna do here now? Alright, so I'm gonna say current, okay, pointing to data, which is its own data. That means that same malloc, okay, which is a heap memory. So I want to say the data here should be equals to, let me say 100. Okay, so since current is pointing to that, so what I'm gonna do, okay, I can also say current, okay, so we like to make it points to null. So I will say current points to link, okay, let's say equals to null, and that is it. Okay, so this is how we assign new value to current, to the member of the struct, okay, to the member of the struct. So what I'm gonna do here is to copy this 3 line of code. So I'll press escape, Y and 3, and that copy is. So I will now come below here and press P. Now you can see I just paste that 3 line of code. So I'm gonna edit that, press I for insertion key. So here I'm gonna pass in, instead of first, let this be second struct node. Then instead of first here, also let this be second. Okay, so this will be called, instead of head it will be called current, and here instead of head it will be called current. All right, I'll put a space there. Yeah, okay. So, and here instead of first also it will be called second. All right, so that is it. So how do we now print the data? Okay, so we want to go through the head. So if we say head, we should say let head point to link, and the link here, if you remember here, we say link, head link is equals to current. So we are like merging those two memory heap space. Head and link is now holding, head is now pointing to link through its own link of head. So we'll now come down here and say head pointing to link. Okay, that was not spelled well, it should be nk. They will now say pointing to data, so that will give us the value of what data is, which is 100. Then the same thing here, we say head pointing to link, okay, which is also pointing to link again. So just give a clear comment of what we are doing. So this is what we are doing. We say head, okay, points to head points to link to access the data, point to link to access the data of current, and the same head point to link and also point to link again, and that is it. So I will just expand the terminal a little bit so that it fits the whole screen. So here we should also get nil, but here we will not get a nil anymore. So here we contain address of current. All right, so this is it. Very pretty, guys, isn't it? So I would like to print a new line here, all right, so that everything looks nice. So I will do \n/n, and that is it. So if this program is right, we should have everything well set and I'm ready for execution. So clear the screen again and I will compile. So the program compiles ls. So we run the first one, single linked list, and that is it. Then we run the second one, single linked list 2, and kaboom. Now you see first struct node pointed to 50 have the address of current, and second struct node, this is it, we have 100 and the address points to nowhere. Okay, so if you like what I did, please make sure you give me a follow on my TikTok and make sure you subscribe to my YouTube channel. So have a nice day, guys. All right, bye, see you, bye.